Here we have this kind of crazy function that we can decompose into a series of less complex functions. So how we start with this is we see that we have 1 over a whole bunch of stuff, right? So the outside function here, which we'll just call f of x, is just going to be 1 over x, okay? What are we plugging in for x? We're plugging in all of this junk right here. So now we need to decompose all of this, right? Well, we're going to work outside in. So we can see that we have a bunch of stuff under this square root sign, all plugged in under the square root. So we can call this next function, g of x, equals square root x, right? So what is plugged into square root x? Well, we have all of this junk now, the absolute value of 3 to the x plus 2 plus x plus 2 squared, right? Well, let's keep working outside in. So now we have this absolute value sign. So it looks like we have something plugged in. Oops, sorry, I didn't mean to do red. It looks like we have something plugged into another function, h of x equals absolute value x. Okay, what's plugged in to absolute value x? We have 3 to the x plus 2 plus x plus 2 squared. So now this is where it starts to get a little more tricky, because there's going to be one function that won't be able to be decomposed in the way that we want it to. So if we look at this, we see an x plus 2 that shows up twice. So x plus 2 must be getting plugged into something. So what we're going to do is we're going to replace x plus 2 just with x. So let's say, I guess we have to call this k now, k of x. Okay, we'll say that's 3 to the x power plus x, right? Because what gets replaced, what are we plugging in for x? We're plugging in x plus 2. That's our final function. So we have f of g of h of k of x so far. So I guess we need one more. So we'll just call it j. So we'll say j of x. And j of x is x plus 2. All right, so we ended up having 5 functions that we are composing together to come up with this kind of super function. So we say this super function is equal to, if I get the number of parentheses right here, it'll be a miracle. Okay, it's f of g of h of k of j. 1, 2, 3, 4. Oh gosh. Of x. 1, 2, 3, 4, 5. Okay, I think that's right. So we're plugging in the function j of x to k of x, and then we're plugging in those together into h, and then we're plugging all those together into g, and then all those are going into f. So how function compositions work is we're actually plugging in a whole function into another function. So for example, if we want to do k of j of x, say we want to do k of j of x. Okay, well this is the input for k, it's j of x. So instead of writing x, our input, we're going to put whatever j of x is, which is x plus 2. So usually what I do here is I do 3, and then I'll just put parentheses in place of x. Wherever I see an x, I'll put parentheses. What goes in those parentheses is j of x. So we say 3 to the x plus 2 plus x plus 2. All right, well then where's that going to go? That's going to go into h. Right? So we're going to take k of j and plug it into h. We get absolute value signs around this. And then where are they going to go? They're going to go into square root x. So then we get square root of the absolute value of k of j. And then what are we going to do with those? We're just going to shove it into the denominator, because that's the input for f of x. And then we end up with this super composition. So you want to be able to go both ways. You want to be able to decompose functions, but you also want to be able to compose functions.